So how do we assess the fourth regression assumption where the residuals, the errors are uncorrelated? So we're going to use what we call an autocorrelation function. So the autocorrelation function measures the correlation between the residuals at various lags. So what do we mean by various lags? I'm going to show the next picture to represent, right? So if they're insignificant, it means they are not statistically significant. So this is an example of the ACF plot of the residuals. So these horizontal lines provided in R represent significance. So basically so this first line over here is for lag of 0. So that one's the one that we usually ignore because theoretically this is always going to be 1. This is the ACF, the autocorrelation function when the lag is 1. So what do we mean by lag is 1? So lag of 1 means if you're looking at the correlation between residuals that have a difference of 1 time point. So if you're looking at the correlation between the first residual, second residual, and every pair where the difference in the time point is 1, so between the second and third residual, between the third and fourth residual, so on and so forth, right? We are basically looking at the correlation between all pairs such that the difference in that time point is 1. So in this situation, if you kind of squint really hard, you can kind of see that this correlation function is a little bit beyond the significance line, which tells us that the first lag does have a statistically significant correlation. So ideally, all of these lags ACS for all the different lags beyond 0 should be within the blue bands, right? If they're within the blue bands, we say they are statistically insignificant. So in this case, we have this one that seems to be significant. So that's not good with this example, right? So they all should be within the blue bands beyond lag of 0. Lag of 0 will always have an autocorrelation of 1. The last thing that we can look at is to check the for assumption. So this should be assumption number 5 over here. We can check the normal probability plot of the residuals to check for the normality assumption. So the normal probability plot basically plots the expected value if we do have a normal distribution, and then you want to compare where your residuals fall and do they fall close to the expected values. The normal probability plot looks something like this. There's usually a line here. This line represents the expected value if the residuals follow a normal distribution. So ideally, all these residuals should fall close to this straight line. So in this example, right, they don't. So this kind of tells us that the normality assumption is a little bit suspect over here. So ideally, again, they should fall close to the straight line. Now, truth be told, it turns out that people have done studies to show that this normality assumption is actually the least crucial out of all of them, right? So the previous assumptions, right, that they have to have a linear relationship, the mean of the error should be 0, the variance of the error should be 0, and that the error should be uncorrelated. Those are the most important assumptions. If there is a huge deviation from the normality assumption, then it could be an issue. But people have shown that the normality assumption is the least crucial. And so some people say that the regression model is robust to this assumption. That means even if this assumption is not met, it doesn't quite impact, right, the analysis.